In section 5.5, it's kind of just a continuation of 5.4 with the definite integral. I have up on the screen now the example that I started off section 5.4 with this graph right here is the function f of x equals to x, and I shaded between x equal to -2 and x equal to +2. And when we did the integration of the function f of x equals x between -2 and 2, we got 0 for an answer, because definite integrals give me net areas as opposed to gross areas. So if I just entered the function f of x equal to x, you can see the graph looks more or less like what I have on the screen. And if I calculated the area doing the integration, doing second calc integral number 7, backwards on my calculator, so lower limit first, upper limit second, this comes out to be a 0. This is because the area of the triangle beneath the x-axis is considered negative when you were doing definite integrals. The top triangle had a base of 2 and a height of 2, and the top triangle has an area of base times height over 2 for a triangle, so it's 2 times 2 over 2. So the top triangle had an area of 2 times 2 over 2, which is 4 over 2, which is 2. The bottom triangle also, it has a height and a base of 2 and 2. And the bottom triangle also has an area of 2 square units. But when we're integrating, areas above the x-axis come out positive, areas beneath the x-axis come out negative. Let me show you that the best I can. If I just did a calculation of the integral between -2 and 0, that's just going to calculate the integral for this, and it's going to give me the number -2. It gives me the area of the triangle, but because it's beneath the x-axis, it nets the area out to be negative. So if I did this computation, found the area between x equal to -2 and x equal to 0, I get the area, the integral for the lower triangle, which is its area, but negative version of its area. And then similarly, if I integrated from 0 to 2, that same function, let me clear the function so you can see the calculations better. So when I do this calculation, second calc f of x, start at -2, end at 0. It's just doing the lower triangle, and the definite integral value is -2, even though the area is +2. Because this triangle is beneath the x-axis, the definite integral comes out negative. If I did this integral, let me just clear the function, re-enter the function so it clears out the shading. If I do second calc and integrate between 0 and 2, you'll see the top triangle has an area of +2. Both triangles have an area of 2, but when I integrate between -2 and 2, I get 0 because the areas net each other out. In this section, we're going to want the gross area as opposed to the net area. So in section 5.5, we're going to need to do exactly this. We're going to need to compute the area of the region of the graph that's beneath the x-axis, get a number for it, and make that number positive because I'm not wanting the areas to net out. So I'm going to calculate the area beneath the x-axis. It's going to come out negative when I integrate. I'll make it positive, and then I'll calculate the area above the x-axis of the graph. I'll keep it positive, and then I'll get the gross area. So for this particular graph, I would say the net area, if you wanted to count the region beneath the x-axis having negative area, the area of the first triangle, I would say it has a -2, and the second triangle +2. The net area is 0, and that's what definite integrals compute. If I want the gross or combined area, I don't know if gross is the right word, but feels right. The gross area, the bottom triangle has an area of 2, the top triangle has an area 2, combined they have an area of 4. So in section 5.3, actually section 5.4, we weren't concerned about the gross area. All the definite integral computations we did gave the net area. In this section, we want to do the gross area. It's not particularly hard, but I can't find a gross area in one computation because it nets out cancels out the regions above and below the x-axis. So all we're going to do in this section to determine the gross area is we're going to calculate the area of the graph beneath the x-axis. It's going to, with an integral, it's going to come out negative. We're going to make that negative number positive, and then we're going to calculate the area of the graph above the x-axis. It's going to come out positive. We're going to leave it positive, and then we're just going to add the numbers together. That's essentially all we're going to do in this section, is instead of doing one integral for the whole region that nets out regions, areas beneath and above the x-axis, we're going to do 2 integrals and add the areas together. Let me skip through my notes a little bit and do a visual example of what I'm talking about. So when we get in the homework, I'm going to give us some graphs and just get us used to understanding this concept. So I wrote an example, but I needed to font it up big enough so it's taking multiple sheets to get it all kind of so it could display simultaneously. And what I'm going to do, the first 4 problems in this section, maybe it's even the first 10 problems, gives us one graph of some feature with 3 separate shadings. A shading above the x-axis, a shading beneath the x-axis, and then the 2 shadings imposed on a single graph. And what we're going to do is our goal is to find the gross shaded area as opposed to the net shaded area. So we're going to calculate this area. It's going to come out positive. We're going to leave it positive. We're going to calculate this area. Because it's beneath the x-axis, it's going to come out negative. And because I'm not wanting to net out the negative and the positive, I'm going to make that negative number positive. And then to get the combined shaded area, the total area shaded, not the net shaded area, I'm going to add the 2 areas together. The positive version of this area plus that area. We're going to do it all on our calculator until we get a little bit deeper into the section. We'll do a little bit by hand, but a chunk of this will be on our calculator. So this example is completely, I want it to be done on the calculator. It says use integration on my calculator to determine the area. And it goes, the function is 3x squared minus 12. And it goes between x equal to 2 and x equal to 3. So what I'm going to do on my calculator, I'm going to enter the function y1 as 3x squared minus 12. And then I'm going to choose that f of x dx option, that option 7. Under the second calc screen. And then for lower limit, because it does it backwards on my calculator, I'm going to do 2. And for upper limit, I'm going to do 3. My calculator is going to produce this picture for me, and it's going to tell me what that area is. Apparently it comes out exact, which kind of surprises me. But let me do that right now. So for part A of this question, just wants me to find that area. To find that area, I need to know the function and the bounds on the x's. So in my y1, I'm just entering the function 3x squared minus 12. I don't really necessarily care exactly what the window is. It doesn't have to be matched up with my screen. My screen goes like between -4 and 4 and -3 and 4. If I wanted to match it up, I could change my x's to make it look more like the screen. And I can change my y's to make it look more like the screen. My y's look like to go between -14 and 18. Ultimately, I don't need to copy a picture. I probably don't need to match the picture of the graph that I have displayed. But this is going to look more like the graph that's presented because I can kind of see what I might have used for a window. -14 for x min, y min, positive 18 for y max, maybe negative 3 for x min, maybe 5 for x max. Doesn't matter. I have the function in y1. Let me get this area by going second calc, going down to option 7, lower limit 2, upper limit 3, and that tells me that that area is 7. So for part A, use integration on my calculator to determine that area. The answer to part A is that area is just 7 or 7 square units. Don't really know what the units are, so I just often just write a number. For part B, I want to find this area, and this goes from 0 on the x-axis to 2 on the x-axis. It's the same 3x squared minus 12 function. So I have the same function in my y1. I don't need to update that. I'm going to do the integral computation, and I'm going to do the lower limit of 0 and the upper limit of 2, and that's going to give me a negative number. I guess it comes out to negative 16. If I wanted a net area, the net area of these two things would be negative because there's more region shaded below the graph than above the graph. But since I want a gross area, I'm going to make that positive. So second calc, go down to option 7, start at 0, end at 3, and it gives me negative 9. I don't know why I have negative 16 here. I should double check this. I don't want to do it by hand. Did I do something right or wrong? Let me do this again. Why? I might have typed wrong numbers in. Second calc, serpent calc. I think I might have done 0 to 3 as opposed to 0 to 2. Yeah, I did the wrong numbers. It is negative. So this region has an area of negative 16. If I was doing a net area, I'd leave it negative. But because I want to find a gross combined area, I'm going to make it positive. So I'm going to take the absolute value of it. I did the integral, got an answer for the integral, knew it was going to be negative, took its absolute value and made it positive. This symbolism right here is kind of perfectly what I did. I integrated first, got a number, and then took its absolute value. Part C wants me to find the gross area as opposed to the net area. So if on my calculator, if I entered the integral from 0 to 3 of the function 3x squared minus 12 dx, what it would give me is 7 for the upper area minus 16 for the bottom area. It would give me an area of negative 9. That's actually what I just did on my calculator by mistake. That's a net area. If I want to do the gross area, then I need to do each computation separately. So I do the computation above the x-axis, the number comes out positive, and I leave it positive. Then I do the computation below the x-axis, that number comes out negative, I make it positive. So the upper area was 7, the bottom area, the integral came out to negative 16. I made it positive 16. And the gross area is going to be 23. I will just write 23, but square units might be better to write. So that's the feel for what we're doing. Eventually, we're going to have to do the integrals by hand. But this is exactly the concept of what we're going to do. Each problem, if it's not given as a graph, we're going to create a graph. We're going to find where the graph crosses the x-axis. It's going to break the graph up into regions, and I'm going to find the area of each region separately. The upper region is going to be positive. I'm going to leave its area positive. The bottom region is going to be negative. I'm going to make its area positive. When the instructions say find the total shaded area, that means it wants to sum up the two areas, taking each as a positive. So when we get into the homework, there's going to be some algebra problems, and they're going to be worded just like this. I'm going to give you a function, and I'm going to give you an integral. So here, so the function 4x minus 12, I gave an integral from 2 to 5. I'm going to want to find the gross area as opposed to the net area between 2 and 5 of this function. Well, the first thing I need to do is I need to sketch a graph and find the x-intercept. My graph doesn't have to be that great. I'm I'm going to borrow a graph from my calculator here in a second, but before I graph at anything, I'm going to find the x-intercept. I find the x-intercept in part B by just taking the function and setting it equal to 0. This is going to tell me where the graph crosses the x-axis. That's a big important point because that point's going to come in both of my integrals. So algebraically, the x-coordinate of the x-intercept is 3. So the x-intercept is the point 3, 0. I'm going to mark that point, and now I'm going to sketch a graph from my calculator, and I'm not going to copy it with any accuracy whatsoever, other than I'm going to make the graph go through the x-intercept, and I should be able to tell just by looking. So part A wants me to sketch a graph, but quite honestly, if I don't have the x-intercept plotted properly, then my graph is not going to be worth as much as I want it to be worth. I'm going to go back to a zoom standard window. I don't remember exactly what I tweaked my window to, but this is fine. So this looks like this. So I don't need any more accuracy than that. I just need to have the correct x-intercept. So this, I sketched a graph with the aid of my calculator. I made sure that it went through the right x-intercept. Now I want to find the total area. How do I find the total area between 2 and 5? Well, I'm going to make up two regions. I'm going to do the region between 2 and 3, and then the region between 3 and 5. So I'm going to have to calculate two areas, and this time by hand and not on my calculator. So I need to find this area, which is beneath the x-axis, and it goes between 2 and 3. And I need to find this area that's above the x-axis that goes between 3 and 5. The 2 and the 5 were given numbers, and the 3 between the 2 and the 5 I got from my algebra. So it doesn't matter which area, which triangle I found the area first, but for part C, I need to get the combined area. I'll do the hard one first. I'll do the lower triangle. I'm going to find its area by hand integrating. I'm going to go from 2, which is the beginning of my integral, to 3, which is where the graph crosses the x-axis, of the function 4x minus 12 dx. Because this graph is beneath the x-axis, I know my answer is going to be negative. I'm going to absolute value it and make it positive. So let me do this integral off to the side. So that integral, I can write it as, without the numbers just to make it quicker to write, I can write it as the integral of 4x dx minus the integral of 12 dx. The 4 I can bring out front here. This is going to be the integral of 4 times x dx minus the integral of 12 dx. This guy, I'm going to add 1 to the exponent. The new exponent's going to be 2. I'm going to multiply by 1 over the new exponent, which is going to be 1/2. I still have the coefficient. The second, that's an integral of a constant, so you're going to get 12, in some case, just the constant times x. This fraction reduces by 2, and you're going to get 2x squared minus 12x. So this is the result of that integral. Now I need to get a number attached to it. And I get a number attached to an integral by plugging in the upper number and then the lower number, and then subtracting. So for the upper number, it's going to be 2 times 3 squared minus 12 times 3. Don't want to really mess up right now, so I'll do that on my calculator. So 2 times 3 squared minus 12 times 3. The upper triangle has an error. Well, the upper number gives me a negative 18. And now I'll do the lower. 2 times 2 squared minus 12 times 2. That's going to be 2 times 2 squared minus 12 times 2, which is minus 16. So the integral that's inside my absolute values, it's going to be found by taking negative 18 minus negative 16. I subtract the two numbers, the number from the top number minus the number from the calculation on the bottom. So minus 18 minus negative 16 comes out to negative 2. So that triangle's area from my calculus comes out to negative 2. But I'm doing a gross area, so I'm going to make that number positive. And the number that I'm going to use for that area is positive 2. Done with the bottom triangle, I'm going to move on to the top triangle. For my top triangle, the area should come out positive because that whole top triangle is above the x-axis. The top triangle goes from the x-intercept, which has an x coordinate at 3, to the ending number that I gave, which is 5. And it's the same 4x minus 12 dx, which means I already know what the integral is. I've already integrated this function, so I'm not going to reintegrate it. I'm just going to use the result of the integral, 2x squared minus 12x, and plug the numbers 5 and 3 in. I'll do 2 times 5 squared minus 12 times 5, and then the same with the 3. So 2 times 5 squared minus 12 times 5 is going to give me negative 10. And then I'm going to do 2 times 3 squared minus 12 times 3. And that computation I did up here, so I don't need to do it again. That's negative 18. So for this integral, I do the number from the top computation, negative 10, minus the number I got from the bottom computation, negative 18. And when I do negative 10 minus negative 18, I get 8. So bottom triangle, integral comes out to negative 2, area is actually positive 2. Top triangle, integral comes out to positive 8, area is actually positive 8. The answer to part C of this example wants me to find the total area, the combined total area making both positive. So the total area is going to be the area of the bottom triangle, which is positive 2, plus the area of the top triangle, which is positive 8. The total area is 10. That's the bulk of the section. Either I'm going to give you pictures that have 3 different graphs and we'll find the areas on our calculator, or I'll give you a function that we're going to have to find the x-intercept, sketch, and then find the gross area by calculating 2 separate integrals, an integral of the region above the x-axis, an integral of the region below the x-axis. So let's jump into some homework problems. We'll do the calculator homework first, and then the by hand homework will spill off until our part 2. So question 2 gives me 3 individual graphs, and all of the same function, x squared minus 6x. And what I'm supposed to do, just using my calculator and not by hand, is calculate the area above the x-axis, the area beneath the x-axis that's shaded, and then the gross combined area. And this one's going to come out to some decimals. So let me look at the first region. The numbers on the x-axis aren't showing up so well. This first region goes from x equal to negative 1 to x equal to 0. So on my calculator, in y1, I'm going to enter the function x squared minus 6x. And for this one, I'm going to do that option 7, the integral of f of x dx, and I'm going to do lower limit of minus 1, upper limit of 0, and I'm going to round to 2 decimals, and I think I'm going to get 3.33 because I have it written off screen. So y equals clear x squared minus 6x. I don't really care so much about the graph, but that looks pretty much so like what I have on the screen. So second calc, option 7, lower limit 0. Oh, I messed up. Second quit. Second calc, option 7, lower limit -1, upper limit 0, and the answer for part A is just going to be the number 3.33. That's the total area of the region that's drawn. I'm going to move on to part B, and this portion that's shaded starts at the origin, which is x equal to 0, and it ends at x equal to 6. And it tells me there it goes between 0 and 6, just in case it wasn't evident. Let me find the area by going second calc, option 7, start at 0, end at 6. It's going to draw the shading for me. And it gives me -36. The integral is negative, but I want to make the area positive by absolute valuing that, make that negative number positive. The answer to 2b, the shaded area, gross shaded area, is 36. 2c wants me to find the total shaded area between this region and that region. And the region up here has an area, gross area of 3.33. The region beneath the x-axis has an area of 36. If I just add those two individual areas together and I get 39.33, that's going to be my answer to part C. That's the total shaded area. If I integrated this over the whole region, I'd get, I don't know, whatever 36 minus 33, 36 minus 3 is like 32 point something. It would net out it would be a negative area, and it would net out those two numbers, but we don't have to worry about that in this section. So these are friendly, and even by hand, I didn't make any ugly integrals in this section. So we'll move on to 4. 4 gives me a lovely line, which is so easy to integrate by hand even. And it wants me to do a part A to find the area above the x-axis, a part B, find the area by integration on my calculator below the x-axis, make the number positive, and then a part C, find the combined area. So for part A, in my y1, I'm going to enter the function 5x plus 10, and I'm going to activate that f of x dx because it tells me I could use my calculator. And I'm going to do lower -2, upper +1. The answer is going to be positive, so I'm not going to need to do a thing to it. So y equals 5x plus 10. And then second calc, option 7. How different the slope is on the line it looks because my window is different, but it doesn't matter. My calculator doesn't care if the windows aren't matching up. This area right here, the answer to part A, the triangle that's pictured there has an area of 22.5. I could have probably calculated the area with just a triangle formula, but I wasn't necessary. For part B, the triangle that's pictured has the same 5x plus 10, but the region goes from -4 to -2. So again, in this, I'm going to have the same function in y1. This is the same graph of y equals 5x plus 10, or f of x equals 5x plus 10. I'm going to check the f of x dx, and I'm going to go lower is -4, upper is -2, and it's going to come back as a negative number. I'll make it positive. So now second calc, option 7, lower is -4, upper is -2. My calculator tells me that the integral is -10. I'm going to make that -10 positive by taking its absolute value. The answer to part B, the shaded region, gross shaded region, is going to be +10. For part C, it just takes the first graph and the second graph, shades them all together, wants me to find the total shaded area. The total shaded area is the area beneath the x-axis plus the area above the x-axis. And when I add those two numbers, my answer to part C, the area is going to be 32.5. And I guess square units would be nice, but I often get lazy in this section and don't actually write the square units. I don't know, maybe let's do one more. It almost seems, it almost seems, oh no, I think these are the by hand ones. Okay, that's the end of the calculator, and then the rest of the section we're going to do by hand, and I have to be a little more clever, so I'll stop and we'll do a part 2. And everything else, the next 4 or so problems are all doing it by hand, but the concept's the same, other than the graph's not going to be provided. We'll need to create the graph, and we're going to integrate by hand.